Welcome to Gliese 581c. This planet is only 20 light-years away from us. It is located in the constellation Libra and is one of the smallest rocky planets found outside our solar system, but this does not mean that Gliese 581c is small. This planet is still a super-Earth, and its mass is 5 times that of our planet. But the possibility of liquid water on its surface has excited scientists. There is no dryness. Not even kilometers beneath the water's surface. But as we descend into the depths of the sea, the pressure rises. At a depth of 10,000 meters, we reach a point equal to the bottom of Earth's deepest oceans. We pass 30,000 meters. The pressure becomes so intense that, surprisingly, water takes on strange forms. At a depth 10 times greater than the deepest point of Earth's oceans, we reach the seabed. When we have a vast amount of water, at the ocean floor an enormous pressure is formed, exceeding 1 million atmospheres. And that pressure changes the ocean water into a state where it can compress water, turning it into ice. The water molecules that freeze in a freezer are disordered, but if water freezes under high pressure, the molecules become ordered. Ice can also exist within our solar system. Europa, one of Jupiter's moons, has a layer of liquid water covered by a thick icy crust. The pressure from this crust is so high that ice can form within these hidden seas. If we melt Europa's surface ice, it could reveal a water world, similar to Gliese 581c. It is possible to imagine that life could exist on a water world. Water is essential for life on Earth. Everywhere on Earth where there is water, there is also life. Nowhere on Earth can you find a drop of water that is completely clean and free of life, unless you place it yourself in a microwave. In this water world, bacteria or any form of life within the ocean could exist. But not all super-Earths are water worlds with the possibility of life. When we talk about super-Earths, we refer to two main groups, one rocky with little water, and another covered in water with an endless ocean. But we must also add a third group, the rare super-Earths, Earth-like planets, known as carbon planets. Carbon planets differ from anything we have ever seen. A place with unknown chemical compositions, but rich in earthly treasures. Across our galaxy, barren, poor, and uninhabitable planets exist. But science is searching for a new type of planet. A world filled with valuable treasures. In the solar system, the sun and all the stars near us have more oxygen than carbon. But if we imagine a place in the universe where carbon is more abundant than oxygen, then its formation would be different. Spectral surveys show that carbon is very abundant at a distance of 26,000 light-years, near the center of our galaxy. The planets formed in this region are rich in carbon. The morning sky on a carbon planet is not clear and blue at all. Imagine a yellow haze, with black clouds formed from soot. And as we go deeper, we can imagine lakes made of compounds such as methane or benzene. Imagine foul-smelling pits of black sludge. Black sludge, like an oil well. With little water in the atmosphere, or even none, the air is also made of carbon compounds. Methane, butane, pentane, benzene, and all the different carbon compounds that are separated when gasoline is refined. Therefore, one day benzene may rain, and another day butane may fall from the sky. Although carbon planets may seem strange, the quality of the air is familiar to some. The air on a planet rich in benzene could in fact resemble the air in Los Angeles. The same abundant pollutant particles that come out of car exhaust pipes. Which unfortunately, we have gotten used to. Despite the pollution, carbon planets can have one bright positive aspect. You might see diamonds there, because the planet may be composed of significant amounts of pure carbon, and when pure carbon is compressed, it turns into diamonds. The mysteries of strange planets like these remain unknown across the galaxy. But astronomers will not rest until they find a holy land. A planet like our own. A planet that can host life, that is, the next Earth. Every star has planets that are nearly the size of our Earth. We believe that inherently every star has several Earth-mass planets or super-Earths. Therefore, if there are, for example, 200 billion stars in the galaxy, perhaps it means there are 400 billion Earths in the galaxy, or maybe even more. The Kepler Space Observatory is the first instrument capable of finding one of these planets. Kepler looks at the constellation Cygnus in the night sky and observes 100,000 stars, taking continuous photos of them, minute by minute. Well, Kepler's mission is simple. Among those 100,000 stars, it searches for one that has dimmed. When a star slowly dims, it means a planet is passing in front of it, blocking its light. The duration of the dimming and the amount of light lost provide scientists with information about the size of the planet and its distance from the star. In fact, it is a technique that changes the course of science. Scientists estimate that the Kepler mission will lead to the discovery of at least 50 unknown Earths. Conditions on an unknown Earth could allow life to evolve in a different way. Whatever that sign may be, it will mark the first chapter of the greatest scientific story in history.